From fine fibers, the future of aerospace takes shape. The journey begins deep within the Earth, unearthing vital resources for advanced aerospace. The journey begins as vital materials converge towards the heart of B-21 production. Advanced robotics meticulously craft the B-21's composite skin, layer by precise layer. The complex mold shapes the future of aerial dominance, layer by layer. Skilled hands ensure every detail meets the rigorous standards of aerospace engineering. Precision is paramount as advanced composite parts enter the curing cycle. Under immense heat and pressure, these components transform. Expert technicians ensure every parameter remains exact. Precision machining begins, shaping raw titanium into a crucial component for the next generation bomber. American machinists meticulously monitor every detail, ensuring flawless execution. From raw block to complex structure, technology transforms materials with unmatched accuracy. Each cut brings us closer to the formidable B-21, a symbol of American engineering prowess. Precision inspection ensures every composite spar meets the highest structural standards.
Check the tolerances on this panel right here, right?
Looks within spec, but let's verify with the main jig calibration data.
Precision engineering guides every component into place, ensuring structural integrity.
Left a bit, steady.
Advanced laser guidance systems ensure every connection is perfectly aligned. Skilled hands and advanced tools ensure the structural integrity of every joint.
Make sure that conduit is fully seated before the next fastener.
Roger that. 3 more clicks.
The B-21 Raider's internal framework takes shape, built for unmatched performance. Precision and expertise are paramount in crafting the advanced composite structures of the B-21 Raider. Every fastener and bond is critical, contributing to the structural integrity and stealth capabilities. The meticulous joining of composite panels creates the B-21's distinctive, seamless profile.
Align the leading edge precisely.
Confirmed. Applying the first fastener now.
Advanced bonding agents are carefully cured, ensuring unparalleled strength and durability. Every detail undergoes rigorous inspection, upholding the highest standards of aerospace manufacturing. Each assembled wing is then prepared for its integration into the bomber's formidable airframe.
This connection point manages the primary load transfer to the main spar. The tolerance here is measured in thousandths.
Expert American technicians meticulously prepare the central fuselage,
All parameters
ensuring
are within
flawless
spec.
integration.
All right, bring it down 5 more feet, slowly.
Copy, descending slowly.
Hold, stop right there.
Teams communicate via headsets, coordinating every millimeter of the complex alignment.
Clear on the left. Hold position.
The gap is almost imperceptible.
Alignment is perfect.
Confirmed. Ready for the next stage.
Slowly, deliberately, the wing sections integrate,
Adjusting now.
a testament to advanced manufacturing.
Alignment is perfect. Data stable.
Excellent. Move to ceiling.
Another wing section is prepared for its critical integration, mirroring the meticulous process. Fasteners are meticulously applied, permanently
alignment on
joining
the leading
advanced
edge.
materials with unmatched strength.
Sign off on section 4.
With both wings taking shape, the B-21 Raider's iconic form begins to emerge.
Make sure the coating is uniform before the next stage.
Precision is paramount. Every inch of the B-21 Raider is meticulously scrutinized to meet exact specifications. Complex electrical pathways are carefully routed through the bomber's
Steady
core.
pressure. Watch the bend radius.
Every connection is vital, demanding absolute precision from the technicians. Every circuit is tested, guaranteeing flawless operational integrity. Every conduit and cable is secured, ensuring robust performance under extreme conditions. From blueprints to finished systems, meticulous attention governs every step.
Charlie, make sure that bundle clears the bracket at station 420.
Reading nominal voltage on the auxiliary line, Sarah.
Almost there. Just keep the tension steady.
The B-21's nervous system takes shape, a testament to American innovation. Precision is paramount as sensitive avionics integrates seamlessly into the B-21 Raider. Each module finds its precise home, critical for the Raider's advanced capabilities. Fasteners are meticulously applied, securing the vital modules against extreme conditions.
Alignment is good. Lock it down.
Confirmed. Diagnostics are running now.
Deep concentration reflects the immense responsibility each specialist bears. The shielded bay is sealed, protecting these vital components for operational readiness. Precision engineering begins with meticulous preparation, ensuring every component is ready. Carefully, technicians route essential lines through the intricate wing structure. Every connection is meticulously tightened with calibrated tools, preventing any potential leaks.
Did you secure the hydraulic bypass?
Yes, just finished it. The fitting looks good.
A final inspection confirms every line is perfectly installed and secured. Engineers meticulously connect systems, initiating vital diagnostic tests. Real-time data streams confirm system readiness. Subtle indicators flash, signifying system integrity across the stealth airframe.
Look at this fluctuation on the primary flight control system.
It's within tolerance, but the deviation is unexpected at this altitude.
Advanced robotics meticulously apply radar-absorbent materials, crucial for stealth. Multiple layers build its stealth capabilities, a testament to advanced engineering. Every millimeter is covered, creating an undetectable profile for the ultimate advantage. Each coat strengthens its ability to evade detection, a silent guardian in the skies. The B-21 emerges, cloaked in advanced stealth technology, ready for the next stage. Stealth gap fillers are meticulously applied, ensuring a flawless, low observable surface for the B-21 Raider. Every seam is sealed with specialized tapes, crucial for maintaining the bomber's stealth capabilities. Advanced materials and skilled hands converge to create an unparalleled, low observable profile.
Did you get the tolerance on this section?
Yes, it's within spec, ready for the next strip.
The B-21 Raider's stealthy exterior is finalized, ready for the next critical phase. Advanced engines are meticulously prepared for integration into the B-21 Raider's stealthy frame.
Looks good. Clear on the starboard side?
Confirmed. Port side clear. Proceed.
With utmost precision, the first engine is seamlessly integrated into the bomber's stealth design. The meticulous process begins anew for the second, equally powerful, stealth engine. Under specialized lights, an expert meticulously examines the bomber's stealth coating. Precision engineering ensures every component of the B-21 Raider integrates flawlessly. The nose landing gear, critical for maneuverability, is carefully integrated into the forward fuselage. Rigorous load testing ensures the landing gear can withstand the demands of flight and operations. A moment of unveiling as the B-21 Raider prepares for its public debut.
Tow bar secure, green indicator flashing.
Copy that. Moving to starboard checks. Clear for engine diagnostics.
With precision and power, the B-21 Raider emerges into the light.
Speed 1/2 knot. Over.
A new era of aerospace excellence takes its place on the tarmac. The B-21 Raider begins its powerful acceleration, building incredible speed for its inaugural flight. Effortlessly, the B-21 Raider takes to the sky, a testament to its advanced design and engineering. The B-21 Raider begins its rigorous flight test program, pushing the boundaries of stealth and performance. Alongside its chase plane, the B-21 undergoes close observation during critical flight profiles. Simulated mission profiles over a restricted range test the bomber's operational readiness. The B-21 Raider undergoes rigorous electronic warfare simulations. Every system is meticulously checked, ensuring readiness for deployment. The B-21 Raider is now ready for its operational debut, marking a new era. A
This
proud
aircraft
moment
is a
as leaders
testament to
formally
American
transfer the
innovation.
B-21 into
We are
service.
proud to deliver the future of air power, General.
The B-21 Raider stands ready, a testament to innovation and dedication. Skilled technicians meticulously perform vital inspections, ensuring operational readiness. Every component is carefully examined, upholding the highest standards of aerospace engineering.
Cross-reference the sensor data with the schematic.
It looks consistent, but the tolerances are tight.
Let's run the diagnostic again from this angle.
The B-21 stealth capabilities are maintained through rigorous and precise care. The B-21 Raider stands as a formidable symbol of innovation and technological prowess. Generations gather to witness the future of aerial power.
Technology. It's incredible, the future of aviation right there.
Please keep your hands clear of the display. The B-21 Raider is the most advanced aircraft in the world, built to protect our skies.
A symbol of American ingenuity, inspiring awe and respect worldwide. Automated precision handling ensures that no human contaminants touch the fibers as the robotic filament winder prepares for the primary fabrication phase. A precision ground steel mandrel serves as the internal mold, rotating at high velocity to begin the creation of the reduced diameter fuselage. Layer by layer, the composite shell builds up utilizing a cross-weave pattern designed to maximize the strength-to-weight ratio. As the shell thickens, the reduced diameter profile of the MSE variant becomes apparent, optimized for high-speed atmospheric interception. The winding sequence concludes with a precision thermal cut, sealing the final layer of the composite architecture. The assembly is encased in a specialized vacuum bag, a critical step to remove trapped air and ensure a perfect bond between layers. The fuselage enters the autoclave, a high-pressure oven, where heat and atmospheric force will catalyze the chemical curing of the resin. The result is a cured perfectly cylindrical tube, the backbone of the Patriot MSE, now ready for the integration of its propulsion and guidance systems. Digital calibration ensures the exact placement of every aerodynamic component. Material is removed with micron-level precision to maintain structural integrity while reducing drag. High-tension springs provide the energy required for instantaneous deployment upon launch. The pivot pin is driven home, anchoring the control surface to the primary airframe. A deployment test confirms the spring-loaded action is violent and reliable. This process is repeated for all 4 control surfaces, completing the aerodynamic suite. Phase transition complete. Moving to solid fuel motor integration. The chamber is sealed to create an atmosphere-controlled environment, essential for high-stability propellant casting. A high-viscosity, hydroxyl-terminated polybutadiene slurry is injected, forming the foundation of the dual-pulse motor. The first pulse propellant grain is completed, providing the initial thrust required for supersonic ascent. Laser diagnostics confirm the barrier is perfectly seated, ensuring the second pulse only ignites upon command. Ultrasonic vibration is applied to deaerate the propellant, removing any microscopic bubbles that could cause erratic burning. Internal temperature sensors monitor the exothermic reaction, ensuring a uniform cure throughout the grain's volume. The resulting star grain geometry provides a massive surface area for instantaneous thrust upon ignition. Controlled cooling stabilizes the solid propellant, preventing thermal cracking during the transition to ambient temperatures. The dual-pulse heart of the Patriot is now ready, a powerhouse, capable of hypersonic interception. The nose cone, crafted from advanced ceramics, is prepared to house the most sophisticated radar seeker in the world. The signal processor, the brain of the seeker, is integrated into the core chassis of the ocular unit. Optical bore sighting calibrates the radar's physical axis with its digital target tracking center. Initial power-up sequence confirmed. The Seeker's internal systems report all sensors are operational. A frequency sweep confirms the transmitter's ability to pierce through enemy electronic countermeasures. With the ocular assembly sealed and vacuum tested, the Patriot is now capable of independent hit-to-kill interception. The heart of the P-83 MSE is the hit-to-kill tungsten penetrator designed for pure kinetic energy transfer. Precision laser guidance ensures the penetrator is perfectly centered within the airframe. Heavy-duty mechanical locks secure the core to prevent any shift during Mach 5 maneuvers. This ring houses hundreds of titanium fragments designed to deploy if a direct hit is not achieved. Automated high-torque systems prepare to seal the warhead assembly into the primary structure. Electronic firing circuits are linked, connecting the warhead's lethality enhancer to the flight computer. Onboard diagnostics confirm the kinetic core is live and fully integrated into the missile's logic. A protective composite shroud is applied, shielding the lethal core from aerodynamic heating. With the tungsten lethality core secured, the PAC-3 is one step closer to its final mission. Every movement is controlled to sub-millimeter precision to ensure perfect alignment with the launch guide rails. The modular canister is the primary housing designed for rapid replacement in the field. As the missile seats, the rear interface aligns with the battery data link umbilical. The handshake between the interceptor and its housing is complete. The PAC-3 MSE's modular design allows for 16 missiles to be carried by a single trailer. Physical security is paramount to ensure stability during the violent forces of a launch. The P-83 MSE is now fully integrated, standing ready to defend the theater from ballistic threats. The radar searches for microscopic anomalies in the upper atmosphere, seeking the signature of a hostile threat. The operators engage the target, initiating the identification and verification protocols. Transitioning from search to track, the radar concentrates its energy into a narrow high-power beam for precision lock-on. Data is shared across the theater missile defense network, ensuring synchronized engagement with THAAD and Aegis assets. The fire command is sent. The countdown to intercept begins. Final interlocks are cleared. The ignition sequence is irrevocable. Ignition achieved. The interceptor breaks its seal, beginning its hypersonic journey to the target. Pressure builds instantaneously as the dual-pulse rocket motor's first stage ignites within the launch tube. The guidance system initiates the pitch-over maneuver, aligning the interceptor with the projected intercept point. Structural integrity is tested as the airframe endures massive longitudinal G-loads. Breaking the sound barrier, the PAC-3 MSE generates a localized sonic boom as it enters the supersonic regime. Advancing to Mach 3, the ceramic and titanium components dissipate extreme thermal energy. Entering the hypersonic regime, the air itself begins to ionize around the hardened seeker window. Precision pyrotechnic charges sever the structural link between the booster and the kill vehicle. Reduced to its most agile form, the interceptor coasts at hypersonic velocity, ready to engage the incoming threat. This ring consists of 180 tiny solid fuel rocket motors designed for instantaneous lateral thrust. Milliseconds before impact, the first bank of motors fires. Unlike traditional fins, the ACMs allow for pure lateral translation, shifting the missile's center of gravity instantly. This ballet of fire enables the interceptor to perform maneuvers exceeding 30 Gs. The flight path is no longer a curve, but a series of precise, jagged vectors. Roll control is simultaneously managed, ensuring the seeker's orientation remains fixed. The attitude control motors perform the final high G correction to align the interceptor for a direct hit. The dual control system provides unparalleled agility at hypersonic speeds. The attitude control ballet concludes setting the stage for kinetic destruction. The K-band active radar seeker provides precise telemetry guiding the interceptor toward a direct collision path with the incoming threat. Impact. The hit-to-kill technology translates pure velocity into destructive force, instantly breaching the target's structural integrity. Simultaneously, the lethality enhancer deploys, casting a dense cloud of titanium fragments to ensure total neutralization of any submunitions. A massive atmospheric shockwave marks the point of interception, signaling the complete destruction of the ballistic threat. Kill assessment data is instantly processed, confirming the total neutralization of the incoming tactical ballistic missile. With the mission accomplished, the launching station prepares for relocation, its modular canisters ready for rapid reloading. From fabrication to kinetic vaporization, the journey of the interceptor represents the pinnacle of modern aerospace engineering and defense. Our journey begins deep within the Earth, extracting bauxite, the fundamental element for aerospace-grade aluminum. From ancient sands, the raw materials are meticulously prepared, destined to become the strength of a legend. The journey of an F-15 Eagle begins with the Earth's raw resources. From intense heat, raw titanium begins its transformation into advanced aircraft components. Expert operators precisely position the molten metal for its dramatic reshaping. Thousands of tons of force reshape raw material into precision aircraft components. Precision engineering transforms raw materials into critical components for aerospace excellence. Skilled artisans and advanced robotics collaborate to achieve aerospace perfection. Each cut brings the F-15C D Eagle wing spar closer to flight readiness. Precision inspection is vital, ensuring every component meets the F-15 Eagle's rigorous standards. Corrosion resistance begins as a fuselage section is carefully lowered for chromate conversion. The aluminum surface transforms, gaining a characteristic greenish-gold tint. This vital coating ensures the F-15's long-term durability and combat readiness. Precision robotics ensure every F-15 wing receives a flawless zinc chromate primer coating. This crucial primer layer prepares the F-15 surface for its final, resilient combat finish. Automated precision ensures every F-15 component meets the highest standards of preparation. Precision is paramount as massive components are carefully aligned. Every component meticulously fits, a testament to engineering excellence. The rhythmic pulse of the rivet gun secures the aircraft's powerful structure. Finished sections are meticulously inspected, ensuring flawless integrity. Step by step, the F-15C D Eagle takes shape, piece by powerful piece. From a first-person view, we meticulously align the F-15CD's formidable wing structure. Every alignment pin must be perfectly seated, a testament to precision engineering. With precision, the titanium attachment bolts are ready to secure the wing. Each titanium bolt contributes to the F-15CD's legendary strength and resilience. Precision engineering ensures every F-15CD Eagle meets exacting combat standards. Every angle is meticulously checked to guarantee flawless flight dynamics and safety. American ingenuity and craftsmanship are embodied in every aerospace component. Precision and expertise are paramount in connecting the aircraft's critical flight control systems. Every connection is verified against detailed schematics, ensuring flawless performance. Within the fuselage, a complex network of wires and systems takes shape, bringing the aircraft to life. Rigorous electronic testing ensures every circuit functions perfectly, guaranteeing flight safety. With critical systems installed, the aircraft moves closer to its destiny in the skies. Precision and meticulous care define every connection within the F-15's hydraulic system. Hydraulic actuators, critical for control surfaces, are carefully integrated. Each line's path is carefully planned and secured, preventing abrasion or interference. The complex web of hydraulics is now complete, awaiting rigorous system checks. Precision is paramount as the advanced radar system is carefully maneuvered into position.
Lowering now.
Each connection is critical, integrating the radar seamlessly into the formidable aircraft. Rigorous diagnostics ensure the AN, APG 63V3 AESA radar performs flawlessly. The heart of the Eagle, a powerful F-100 engine, is carefully lifted, ready for integration.
The clearance here is minimal. We'll need the specialized rig for the install.
Agreed. Ensure the alignment is perfect before we proceed.
Engineers guide the massive engine with incredible precision,
Copy that.
ensuring
Watching the
perfect
clearance on the
alignment.
starboard side.
With the engine perfectly seated, the critical process of securing it to the airframe begins. With all connections complete, the F-15 Eagle's power plant is now fully installed.
All green for installation?
Precision is paramount as technicians meticulously connect vital systems. Digital schematics guide every critical connection. Navigating tight spaces, every movement is deliberate and precise. Every step is verified against precise digital specifications.
We're seeing an anomaly in the hydraulic pressure readings.
Oh, yeah. See where the electrical harness crosses the bleed air duct.
The engine bay becomes a marvel of interconnected systems. Expert technicians begin the crucial installation of the F-15's complex landing gear system. The F-15 is prepared for its gear swing test, a critical operational verification.
Proceeding to pressure systems check.
The gear retracts seamlessly, confirming its readiness for operational flight. Precision is paramount as the iconic bubble canopy is meticulously aligned for installation.
How did the seal look over here?
It's within tolerance.
Rigorous electronic testing ensures the canopy's critical jettison system is fully operational. The F-15C D-Eagle receives its iconic Mod Eagle camouflage, meticulously applied by skilled hands. A quality control expert ensures every inch meets the highest combat standards. The cockpit comes alive as systems are meticulously checked for flight. With final checks complete, the pilot prepares for a powerful ascent. Accelerating down the runway, the jet gains incredible speed. The test pilot pushes the throttles forward, unleashing immense power as the F-15 roars to life. With a surge of power, the F-15 lifts off, climbing steeply into the open sky. High above, the pilot executes precise maneuvers, testing the aircraft's agility. Every system is put ensuring peak performance and the life for another license. Pen testing to From high above, the vast desert serves as our ultimate testing ground. Every system is calibrated, every maneuver perfected through rigorous testing. Precision flying defines every moment, from high altitudes to terrain-hugging passes. After rigorous evaluation, the F-15 Eagle stands ready for any challenge. Advanced non-destructive testing ensures every critical component meets rigorous combat standards. These detailed checks are vital for the F-15's peak performance and safety. Every detail is scrutinized, ensuring the F-15 is always combat ready.
Schematic. We should mark that.
Flawless inspection on the wing. Good job, let's pack it up.
Rigorous quality control ensures every F-15C D Eagle meets the highest combat standards. Every critical parameter is scrutinized, ensuring mission readiness and pilot safety. Only after exhaustive testing and review is the F-15 Eagle certified for its vital role. The finished F-15C D Eagle is ready for its mission. With logbooks exchanged, a new era of defense begins. The F-15C, bearing new squadron markings, prepares for its maiden flight with its unit. It ascends swiftly, joining its fellow Eagles in a flawless aerial display of formation flying.
This connection matches the diagram here.
Confirm. Go ahead and torque it.
Skilled technicians meticulously ensure peak performance, upholding the F-15's operational readiness. At the museum, the F-15C Eagle stands as a testament to its powerful legacy. Its enduring presence inspires awe, ensuring its story is remembered for generations. Precision and power begin here as high-strength steel is forged for defense. Red-hot steel transforms into robust armor plates forged with precision. The journey begins as essential materials head to the factory for production. Precision laser cutting initiates the journey of the Oshkosh LATV's robust chassis components. Skilled technicians meticulously oversee the automated process, ensuring every cut is perfect. From raw steel to specialized parts, the factory floor hums with efficient, advanced manufacturing. Skilled American welders begin constructing the robust frame of the Oshkosh LATV with unmatched precision. Through concentrated effort, every joint is strengthened, forming the foundation of unparalleled durability. Each weld undergoes rigorous inspection, ensuring structural integrity for extreme conditions. Every detail is handled with care, from foundational welds to final structural reinforcement. The strength of every guarantees resilience, forged by dedicated craftsmanship. Precision engineering begins with the meticulous fabrication of each suspension component. Skilled technicians integrate robust shock absorbers for unmatched off-road capability. Drivetrain elements are expertly aligned, ensuring seamless power delivery. Every bolt is torqued to exact specifications, guaranteeing structural integrity. The advanced Take-4i suspension system is now ready for rigorous testing.
All parameters are within tolerance.
Precision and strength define every chassis, meticulously inspected for flawless performance.
This junction here is within tolerance. The laser alignment was spot on.
Let's verify the suspension mount torque.
With every test pass, the LATV moves closer to defending those who serve. The journey of the Oshkosh LATV begins with its powerful heart, a high-performance coastal engine. Teams of highly skilled technicians carefully prepare the engine for its crucial journey to the assembly line.
Sequence initiated for the LATV powertrain installation. All teams stand by.
With utmost care, the engine is precisely positioned over the waiting chassis, ready for integration. Skilled technicians meticulously guide the powerful engine into the LATV chassis.
A little more to the left, steady now.
Got it. Looks aligned.
Every connection is critical, ensuring the LATV's reliability and performance. The intricate electrical systems are integrated, bringing the LATV's brain to life. Every bolt is tightened to exact specifications, guaranteeing structural integrity. Each step is meticulously documented for quality assurance and traceability. Collaboration ensures smooth integration of complex systems.
Let's use the torque wrench now. Hold it steady, securing the fastener.
Every fuel line connection undergoes rigorous inspection to prevent any leaks. Confidence in their work ensures the LATV's readiness for any challenge. Skilled artisans meticulously weld the advanced armored plates, forming the LATV's protective hull. The V-shaped hull design is engineered for ultimate protection against battlefield threats. Each weld undergoes rigorous inspection, ensuring unmatched structural integrity and safety. The capsule armored cabin is built for unparalleled crew protection. Every component is designed for optimal performance and battlefield readiness. From raw materials to a resilient finished product, every detail ensures reliability. Precision is paramount, as advanced armor components are meticulously integrated. Each window installation guarantees unwavering protection and structural integrity. The heavy, blast-proof doors represent another critical layer of defense. Every detail from the seal to the lock reinforces the vehicle's impenetrable defense. Precision engineering unites form and function, bringing the armored capsule to its rugged chassis.
Tapping confirms the seal is secure.
Suspension test sequence initiated.
Values are stable. Looks good.
With utmost precision, the armored capsule descends poised for its union with the chassis below. The capsule settles into place, forming the formidable core of the LATV's protective structure. Each bolt ensures unmatched strength and protection, forging an impenetrable combat vehicle.
That's a wrap on the new LATV. Flawless integration. Well done, team.
Inside the armored cabin, the expert meticulously inspects every weld and seal for uncompromised integrity. Precision engineering ensures these run-flat tires can endure the harshest conditions. Skilled hands work with specialized tools, ensuring every component is perfectly aligned. Each completed wheel assembly stands ready for integration onto the Oshkosh LATV. Expert technicians meticulously connect the vital CTIS pneumatic lines, ensuring flawless performance for demanding terrains.
I've got the cable routed through the frame.
Okay, I'm securing the clamp now. Looks good.
Every connection is meticulously secured, guaranteeing the CTIS operates flawlessly under extreme conditions. Each CTIS connection undergoes rigorous pressure testing, ensuring maximum durability and reliability. Precision engineering ensures every wheel unit is perfectly aligned for attachment. Each lug nut is carefully started by hand, ensuring correct threading before pneumatic tightening. Final torquing confirms the wheel is securely fastened for the most demanding conditions. Precision is paramount as the advanced weapon station is carefully hoisted into position.
Easy now, just a fraction to the left.
Looks aligned. Set it down.
Clear.
Skilled hands ensure perfect alignment, a crucial step
Confirmed
for mission
alignment.
readiness. Integrating critical electronics for seamless battlefield networking and control.
Full functionality.
Precision wiring ensures seamless battlefield communication. Every screen is integrated for optimal crew awareness. Complex networks are expertly crafted for mission success.
Tracing the blue lead now. Connection verified.
Advanced systems are installed with utmost care.
Radio check, testing voice transmission. How copy? Over.
Rigorous testing ensures the LATV's unparalleled protection. Witness advanced engineering withstand extreme forces. Every detail is scrutinized for peak performance. Grueling deep-water fording tests validate the LATV's unparalleled amphibious capabilities. Engineered for extreme environments, it navigates the course with unwavering stability. This rigorous testing ensures absolute chassis durability and operational readiness. On the brutal Belgium block track, the LATV's advanced suspension faces its ultimate test. Watch as the LATV conquers frame-twisting obstacles, its chassis remaining intact and stable. The TAG 4i suspension system dynamically adapts, ensuring maximum contact and control. From harsh impacts to deep ruts, the LATV ensures crew protection and mission readiness. Through every challenge, the LATV proves its unparalleled durability and off-road supremacy. Ultimately, the Oshkosh LATV stands ready for any mission anywhere. Rows of completed LATVs stand ready, a testament to precision engineering. Ready for deployment, a testament to American ingenuity and strength. The journey of precision engineering begins deep within the earth, extracting the very bedrock of innovation. From raw materials, the journey of precision engineering begins. The journey to aerospace excellence begins with advanced materials, meticulously crafted. The journey begins. Vital materials traverse the nation, destined for aerospace innovation. Precision logistics begin the journey of raw materials. Each ingot is meticulously logged into the advanced production system. Precision forging begins, shaping resilient titanium for critical aircraft components. Skilled operators meticulously ensure every critical component meets rigorous standards. Precision engineering begins here, shaping raw materials into critical components for unparalleled aerial dominance. The machine's intricate dance sculpts complex geometries, a testament to modern manufacturing prowess. From raw material to aerospace-grade component, the transformation is a marvel of technology and human skill. Precision assembly begins, marking the critical first steps of structural integrity. The heart of the forward fuselage takes shape, guided by expert hands. Powerful yet controlled, the drill securely fastens the vital frame. Precision engineering requires meticulous attention to every detail, guided by advanced schematics. Every application is critical, forming an unbreakable bond for the ultimate performance. The precision tools are prepared, ready to secure the aircraft's vital structures. Each rivet strengthens the structure, contributing to an icon of aerospace engineering. Precision engineering begins as the major components of the Super Hornet are prepared for assembly. Skilled hands guide the massive sections, ensuring perfect alignment for the Super Hornet. The Super Hornet's form takes shape as its primary sections are finely mated. Each bolt is carefully torqued, ensuring the structural integrity of the aircraft. The meticulous torquing ensures the Super Hornet's legendary strength and aerodynamic integrity. The meticulous structural assembly is complete, advancing the Super Hornet to its next phase.
We are clear on this section.
Post-treatment inspection guarantees the integrity and quality of every coated surface. Robotic precision applies the initial primer, preparing the aircraft for its protective layers. Automated systems ensure complete and consistent coverage across all surfaces. Skilled hands complete the task, ensuring every complex curve receives flawless coverage. The Super Hornet's surface now boasts a perfect primer coat, ready for final paint. Precision measurement ensures every FA18E F Super Hornet meets the most stringent Every connection matters, ensuring the flawless operation of the Super Hornet's sophisticated systems. Every wire, every connection contributes to the Super Hornet's advanced capabilities. Digital schematics guide every step, ensuring absolute accuracy in the complex wiring process. Precision electronics are integrated, powering the Super Hornet's advanced capabilities. The core intelligence of the aircraft, ready for integration. With expert care, the computer finds its place, connecting vital systems. The aircraft's digital brain is now fully operational. The AN APG-79 AESA radar, a marvel of modern aviation technology, is prepared for
Hold position, we have clearance on the starboard side.
Roger that. Steady as she goes.
With surgical precision, the advanced radar array begins its integration into the fighter's formidable structure.
Torque check complete on panel 4. Copy that.
Moving to alignment sequence.
Propulsion technicians meticulously prepare the F-414 engines, connecting vital preliminary lines with expert precision. These powerful F-414 engines stand ready, vital components for the world-renowned Super Hornet.
Straps secure.
Hooks engaged, ready for lift.
Precision engineering guides the powerful F-414 engine to its new home.
Bring it left, easy now. Hold it steady. Down slow.
Skilled hands and keen eyes ensure flawless integration.
Okay, easy now. Bring it up 3 millimeters. And lock the mount.
Each component perfectly placed, a testament to craftsmanship.
Lock sequence.
Did you secure the secondary coupling?
Yes, and the fuel line looks clear.
The Super Hornet's distinctive vertical stabilizers are meticulously bolted into place. The canted tails are a signature feature, giving the Super Hornet its iconic profile. Each component is meticulously integrated, building the aircraft's combat readiness. Hydraulics specialists meticulously install the complex landing gear assembly. Each hydraulic line is connected with absolute precision, crucial for flight safety.
Check the main gear door sequence.
Looks good from here.
Jacks confirmed stable, clear for lowering.
The landing gear retracts smoothly, a critical verification of system integrity.
Alignment confirmed.
Rigorous final checks and data recording ensure
Confirmed.
uncompromising
I've
quality.
updated the digital log for the retraction test sequence.
The test pilot prepares for flight, engaging systems in the advanced cockpit. Engines ignite, their powerful roar signaling readiness for the skies. The Super Hornet maneuvers gracefully, preparing for its ultimate test.
Cleared for immediate takeoff, runway 27. Maintain runway heading.
Position for power, the Super Hornet aligns. Ready for takeoff. The heart of the Super Hornet roars to life, ready for its ultimate test. With incredible force, the aircraft rockets skyward, leaving the Earth behind. Under immense G-forces, the Super Hornet executes a breathtaking maneuver. The Super Hornet triumphs, showcasing unmatched agility and pilot skill. The runway comes into view, guiding the advanced fighter through its final descent. Every correction is precise, bringing the advanced aircraft perfectly onto the glide slope. The ground rushes closer, a testament to relentless training and advanced engineering. Post-flight, a meticulous inspection begins, ensuring every component meets exacting standards. Advanced ultrasonics reveal the aircraft's structural integrity, ensuring peak performance and safety. Every inch of the Super Hornet undergoes rigorous checks, guaranteeing unwavering reliability. Telemetry data reveals the Super Hornet's exceptional performance, a testament to American engineering. Every parameter is meticulously scrutinized to ensure peak combat readiness and safety.
Does the fatigue analysis correlate with this spike, Doctor?
With all checks complete, the FA-18E F Super Hornet is cleared for operational deployment. A moment of pride as the FA-18E F Super Hornet is officially handed over, ready for duty.
Tower, Viper 1, requesting clearance.
Stand by, Viper. Ground crew finalizing inspection.
This represents the culmination of meticulous effort, now ready to safeguard our skies. With her name proudly displayed, the pilot takes her seat, ready for the maiden flight.
Ground complete, clear to taxi.
Roger. Moving to the line.
On the carrier's bustling deck, skilled crews meticulously prepare the Super Hornet for its next mission.
Copy. Stand by for engine preheat.
Every final check ensures the Super Hornet is battle-ready, a testament to unwavering precision.
Confirmed, Chief.
Witness the culmination of aerospace innovation. A testament to engineering excellence, inspiring all. The journey of the M26 Pershing begins deep within the Earth. The journey to forge a tank begins with molten steel, shaped for unparalleled strength. Giant rollers forge glowing steel into the M26 Pershing's formidable armor plates. Raw materials arrive, fueling the mighty Pershing production.
Watch the plating, easy now.
Skilled American craftsmen prepare thick RHA plates for the M26 Pershing's formidable hull. Plasma torches ignite, poised to carve the future armor of the M26 Pershing from raw steel. Each precise cut shapes the critical slope glosses, ensuring maximum protection for the M26. From sides to floor, each M26 hull component is crafted with unwavering accuracy.
This section is clear. Are you ready with the main welder?
Yes, just finalizing the calibration now.
Skilled welders fuse massive steel plates, forging the M26 Pershing's impenetrable hull. Precision and teamwork define this critical stage, ensuring superior structural integrity. Each meticulous weld creates a seamless bond, vital for combat resilience.
Watch the clearance on bay 4.
Looks clear. Keep it moving slow.
Molten steel, glowing intensely, prepares for its transformative pour. Thousands of pounds of molten steel now fill the turret mold, forging a new M26 Pershing.
Keep the flow steady, we're almost at the riser.
Confirmed. Watching the temperature spike.
Massive machines meticulously mill the cooled turret, shaping the M26's formidable protection. Precision engineering ensures the turret ring race is perfectly accurate for seamless operation. Skilled machinists guide the powerful tools, crafting precise openings for the tank's main armament.
72.005.
Confirmed. That's within tolerance.
Skilled machinists begin shaping the Ford GAF V8 engine block with advanced automated machinery. Each engine block undergoes meticulous milling to achieve microscopic tolerances critical for performance. Each cylinder bore is carefully measured to guarantee it meets the M26 Pershing's exact specifications. After machining, each engine block receives a final, thorough quality inspection by expert hands. Precision begins as V8 engine blocks arrive, awaiting expert assembly for the M26 Pershing. Piston rings are expertly fitted, a delicate task ensuring optimal engine performance in seal. The heart of the engine, the crankshaft, is meticulously lowered into its designated position. Valve train components, intricate and numerous, are prepared for their crucial role in engine timing. Cylinder heads are gently lowered, sealing the block and completing the engine's combustion chambers. Steel bars are forged, transforming raw material into the backbone of the tank's suspension. Skilled American workers meticulously monitor each bar, ensuring unparalleled strength and durability. The completed torsion bars undergo rigorous inspection, ready to equip the M26 Pershing. Skilled American hands begin the critical task of assembling the Pershing's robust suspension. Each component is secured with unwavering attention to detail, vital for battlefield performance. Torsion bars, the tank's backbone, are carefully integrated into the hull for essential shock absorption. Molten steel, forged by immense pressure, begins its transformation. Skilled operators guide the powerful press, meticulously shaping the future cannon.
The temperature on the billet is holding steady at 1200. Good. Maintain pressure for another 2 minutes.
Each impact refines the formidable 90mm barrel, crucial for Pershing's power. Inside the gun rifling shop, precision machining begins on the M26 Pershing tank barrels. The specialized cutting head is carefully advanced into the barrel, ready to begin its critical task. Coolant flushes away metal fragments, ensuring a pristine and precise cut. The barrel rotates with micro-precision, aligning for the next perfectly spaced groove. After countless passes, a specialist performs the final, meticulous inspection of the completed rifling. Skilled American machinists meticulously transform raw steel into vital M26 Pershing breech components. Each surface is ground to a flawless finish, ensuring optimal performance and durability. Every dimension is rigorously checked, guaranteeing unwavering reliability for the M26 Pershing. With final inspection complete, another precision component is ready for assembly. Skilled hands begin assembling the complex M26 Pershing breech, piece by precise piece. Each intricate component is meticulously fitted, ensuring flawless operation of the firing mechanism. The powerful breech block undergoes rigorous manual tests, its action smooth and reliable. Skilled hands prepare the powerful Ford GAF V8 engine for its crucial journey into the Pershing. With precision, the powerful engine assembly begins its careful traverse across the main assembly line.
Hold your positions, it's almost here.
Looks like a tight fit.
American ingenuity guides the heart of the Pershing tank into its destined place with meticulous care. The M26 Pershing's power pack is now integrated, a testament to precision manufacturing. The formidable M26 Pershing turret, gun installed, awaits its union with the hull.
We need to check the tolerance right here. Already done the cleaning pass. Tolerances are within spec.
A colossal crane lifts the turret, a precise maneuver requiring utmost skill. Skilled hands guide the massive turret, ensuring perfect alignment with the waiting hull.
The turret alignment is showing a deviation of less than 0.01.
Confirmed. The centerline variance is within tolerance.
With precision, the components lock into place, forming the formidable M26 Pershing. Meticulous assembly ensures every Pershing tank meets the highest standards of readiness. Each component, from optics to armament, undergoes rigorous installation for peak performance. Inside, thousands of internal wires and hydraulic lines converge, a testament to complex engineering.
Check the alignment on the drive sprocket. Looks good from here. Almost finished torquing this hatch down.
Skilled American workers meticulously connect each M26 Pershing tank track link, forming the tank's.
Bring it down slowly now. Watch the alignment. Clear on the left side, a little more to the right. All right, set her down easy.
Teams work in unison, guiding massive M26 Pershing tracks around the tank's robust road wheels and drive sprocket. Precision and strength combine as workers ensure every M26 Pershing track link is securely fastened. The M26 Pershing's imposing tracks take shape, ready for the battlefield. With the tracks in place, the M26 Pershing is nearly complete, a testament to American manufacturing. The M26 Pershing, a symbol of American ingenuity, now moves under its own power. At the proving grounds, the M26 Pershing demonstrates its unparalleled mobility, conquering formidable terrain. Its advanced torsion bar suspension absorbs the shocks, providing stability and crew comfort. At the proving grounds, the M26 Pershing readies for live fire testing.
Acquiring target now. Shell, up, locked, and ready.
Precision engineering ensures rapid reloading and sustained firepower. The M26 Pershings, formidable and ready, depart the factory for their vital mission. These formidable machines, born from meticulous production, now stand ready for any challenge. From raw minerals, the journey begins to forge the high-strength materials for a giant helicopter. The journey to build a Mil-May 26 begins with raw materials transforming Earth's elements into aerospace marvels. Molten aluminum alloy is prepared, glowing brightly for the vital casting process. Each mold is precisely filled, ensuring the integrity of these critical structural components. The foundry environment, ablaze with light and heat, reflects the immense scale of helicopter manufacturing. After cooling, the robust aluminum beams are carefully extracted, ready for the next manufacturing stage. Precision is paramount as specialists meticulously monitor the intense controlled environment of titanium casting. Once cooled, the robust titanium beams emerge ready for integration into the helicopter structure.
The gauge reading is stable across the surface.
Confirmed. No deviation detected.
Advanced tools ensure every titanium beam meets the exact specifications required for the helicopter's strength. Robotic precision begins the casting process, forming critical lightweight components. Advanced robotics ensure precision throughout the casting and cooling stages. Quality control ensures every component meets the highest aerospace standards. Precision begins with rigorous inspection, ensuring every component's integrity. This certified component is now ready for integration into the helicopter's formidable frame. Skilled engineers carefully integrate robust hydraulic pistons, ensuring flawless operation of the massive tailgate. Every connection undergoes rigorous testing, guaranteeing the immense tailgate's reliability.
Easy, E. Bring it down slow. Hold it right there. Looks aligned.
Precision fastening and detailed inspections ensure the hydraulic system meets stringent safety standards.
It truly is a beast, isn't it? The sheer power of this lift system.
And the precision is remarkable, given the scale.
The complex hydraulic system is now fully prepared for its role in the Mi-26's formidable cargo operations. Advanced CNC lathes sculpt critical components with unparalleled accuracy. Skilled machinists meticulously inspect each component, ensuring flawless precision.
Watch the clearance on the blade.
Copy that. Moving slowly.
Teamwork and precision are crucial as workers secure the critical hydraulic joints.
Snap. We are secure.
Precision bolting secures each segment, building the incredibly strong internal bridge structure.
Copy that. Coming up now.
The completed bridge sections are carefully maneuvered and installed into the massive cargo hold.
Steady. Looks good.
Giant hydraulic joint is crucial for the tailgate system, are expertly integrated into the bridge structure. Precision begins with careful inspection, ensuring every component meets rigorous standards. With steady hands, the initial connections are forged, shaping power from precision. Each blade is secured with exacting force, ensuring flawless operation. The turbine begins to take shape, a testament to intricate design and craftsmanship.
Confirming stabilization on the guide rail.
Affirmative. Preparing for the X-ray sequence now.
Precision is paramount. Every compressor blade undergoes rigorous X-ray inspection for structural integrity. This meticulous inspection guarantees the unyielding strength required for heavy lift operations. Engineers begin connecting the powerful twin engines to the central gearbox, a critical step in assembly.
Alignment is perfect, clear for bolting.
Confirmed. Let's proceed with the torque sequence.
Massive bolts are carefully inserted, beginning the robust fastening process. Digital precision ensures every bolt meets the exact torque specification.
Final bolt secured.
Confirmed.
The main drive shaft connection points are meticulously secured, ensuring seamless power transfer. The main drive system, a masterpiece of engineering, takes shape.
The schematics show a slight variation in the multi-alloy stress points here.
We should cross-reference that with the physical assembly immediately.
The integrated drivetrain stands as a testament to precision engineering. Precision engineering guides the heart of this colossal aircraft into place.
Watch the clearance on Sector 4. Clear, holding steady.
Skilled hands ensure flawless integration of vital components.
Clearance confirmed, ready for the wrench.
Every component perfectly aligned for unmatched performance. Precision is paramount. The quality control expert ensures perfect alignment of the critical VR26 gearbox. Each component's exact placement is meticulously verified, guaranteeing the helicopter's operational integrity. From raw steel precision engineering begins crafting the colossal helicopter's vital components. Aerodynamic forms emerge meticulously sculpted to defy the forces of flight. Each surface is perfected, ensuring aerodynamic excellence and structural integrity. The forged and machined blade, now precisely shaped, is prepared for its next crucial transformation. Robotic precision applies a durable composite, enhancing both protection and aerodynamics. Each blade receives a flawless, durable finish, critical for performance and longevity. The meticulously coated blade now moves onward, ready for final assembly. Precision is paramount, as each massive rotor blade undergoes meticulous balancing. Each minute adjustment brings the rotor blade closer to perfect equilibrium. The blade is retested, confirming the accuracy of the adjustments. The final readout confirms perfect balance, a testament to expert craftsmanship. Precision engineering begins with meticulous inspection of every critical component.
Easy now, bring it down slowly.
A fraction to the left.
Copy that. Holding steady.
Intricate rotating joints demand unparalleled precision and expert craftsmanship.
Torque is good. Confirmed.
This connection point here needs to be reinforced according to the updated specs.
Yes, I see the change. We'll need the larger rivets for this section.
Achieving perfect alignment is paramount for reliable flight performance.
Quarter turn clockwise.
Okay, watching the readout. We're in the green now.
Precision engineering is vital for the swash plate controlling the helicopter's flight dynamics.
Easy, watch the alignment pin on your side. Clear.
Going down slowly now.
Every adjustment ensures flawless operation under extreme flight conditions. Linkages connect the swash plate to the blade's pitch control, translating pilot commands. Precision is paramount as the colossal rotor assembly begins its ascent.
Slow down bridge, approaching Bay 4. Copy that, slowing to a crawl.
Skilled operators guide the massive component with expert precision.
Copy that, coming down steady. Looks good right there. Hold it steady. We are aligned.
Precision is paramount as the colossal rotor assembly approaches its final resting place.
Bring it down 50 millimeters.
50 mil, understood. Watch the alignment pin.
Skilled hands guide the intricate components into perfect alignment, ensuring structural integrity.
Looks good from here.
Thumbs up, confirmed.
All right, let's secure the bolts.
The final securing of the rotor assembly begins binding power and structure together. Massive fan blades are meticulously prepared for assembly onto the helicopter's robust hub.
A little lower, hold it steady.
Specially forged steel pins are carefully inserted, beginning the secure attachment process. The meticulous attachment process continues one blade at a time until the helicopter's rotor is complete. Inside the cockpit, skilled hands meticulously connect the complex control systems. Control panels are carefully integrated, bringing the cockpit to life. With final connections complete, the control systems are ready for activation. Skilled technicians meticulously integrate advanced systems for unparalleled flight stability. Skilled fitters meticulously integrate the powerful central crane hook into the helicopter's cargo bay. Powerful steel cables are meticulously guided onto the winch, readying the crane for heavy lifting. The colossal mill Mi-26, still in its raw metallic state, enters the specialized paint facility. Every critical component is carefully protected, ensuring flawless paint application. Robotic precision ensures flawless primer application on the massive helicopter fuselage. The helicopter receives its vibrant custom livery applied with robotic precision. The freshly painted Mi-26 emerges a testament to industrial artistry and engineering excellence. Ground testing begins with first time. In the control booth, engineers meticulously real-time tested power simulation, seam and standards of waterproofing. The colossal Mi-26 prepares for its inaugural flight, a testament to unparalleled engineering. With incredible precision, it masters the skies, a marvel of modern aviation. Its immense power is displayed as it effortlessly lifts a massive cargo container. The colossal Mi-26 stands as a testament to engineering excellence, ready for its next mission. From raw earth, the foundational elements for the M551 Sheridan begin their journey. Raw bauxite ore begins its transformation, meticulously processed for critical tank components. Across vast American landscapes, Vital raw materials journey towards the M551 Sheridan tank factory. From raw materials, precision begins. Essential components for the M551 Sheridan tank. Skilled hands and advanced technology work in concert to ensure the highest quality standards are met. From fiery depths, pure molten aluminum flows, ready to be shaped into crucial tank components. This fundamental step ensures the production of lightweight, durable aluminum crucial for military-grade vehicles. Molten 7075 aluminum alloy, crucial for the Sheridan tank strength, is prepared for casting. After casting, these substantial billets cool, forming the foundational blocks for the tank's hull. The immense 7,075 aluminum billet enters the hot rolling mill, beginning its transformation into skilled American workers meticulously monitor the rolling process, ensuring precision for every tank hull plate. These robust 7,075 aluminum plates cool on conveyors before being precisely stacked.
Manifest confirms grade A, 7175 plates. All 20 bundles accounted for.
Precision begins as raw aluminum transforms into vital components for the M551. Sheridan's rope. Intense plasma jets precisely slice through metal, shaping the tank's defensive armor with controlled power. Skilled American craftsmen meticulously inspect each part, ensuring every dimension meets exact M. These precisely cut components are now ready for the next crucial stage. The M551 Sheridan's expert assembly. Massive aluminum hull plates are precisely positioned, forming the foundation of the M551 Sheridan. The arc ignites, sparks fly, as skilled hands begin joining the vital aluminum sections. Coordinated teams work in unison, meticulously crafting the tank's robust aluminum shell. Multiple welding stations hum with activity, assembling the formidable Sheridan hull section by section. Behind the glare, American welders demonstrate unparalleled focus, forging the strength of each tank.
The tolerances on this weld are exceptional, exactly to spec.
Agreed, the craftsmanship is flawless.
Precision machining begins, shaping raw steel into the iconic M551 turret. The main gun mount takes shape, vital for the Sheridan's powerful armament. Coolant reveals the flawless finish of meticulously sculpted steel. The M551 turret, transformed by advanced machinery and skilled hands, nears completion. Precision engineering brings these complex systems to life. Vital lubrication ensures smooth relations. Each component is meticulously secured, guaranteeing unwavering structural integrity. Careful integration merges components into a formidable weapon system.
It's gripping. One more turn should do it.
The formidable 152 millimeter gun/launcher prepared within the M550. The massive 152 millimeter gun barrel is carefully hoisted, ready for precise placement into the turret's core.
Easy. A little more to the left.
A little more to the left.
Component of the gun's mounting is on. Engineers meticulously verify every dimension and angle, ensuring the gun's precision is flawless.
A little more.
Okay. Perfect.
Every movement of the M551, Sheridan's gun, is rigged, guaranteeing battlefield readiness. With its primary weapon integrated, the M551 Sheridan's turret stands ready for further assembly. Precision begins on the engine assembly line, where advanced robotics initiate the build. Component preparation is meticulous, ensuring every part meets exact specifications. Pistons are expertly seated within the engine cylinders, a critical step for performance. The heavy crankshaft is precisely positioned, forming the engine's rotating core. Expertise ensures every critical bolt is torqued to exact specifications. Another expert ensures all fasteners are perfectly secured for optimal engine performance. The completed engine ready for the next stages of assembly. Precision engineering begins with each torsion bar, crucial for the Sheridan's agile suspension. Each torsion bar is precisely integrated, forming the backbone of the Sheridan's innovative suspension.
Easy now, lower it slowly. Make sure the alignment pins match.
Looks good from here. Go ahead and clamp it down.
Large road wheels for the M551 Sheridan arrive, ready for precise integration. Expert hands carefully position each large road wheel onto its designated suspension arm. Securing the road wheels is a meticulous process, critical for the M551's battlefield reliability. Completed M551 suspension units are now ready for seamless integration into the tank's aluminum hull.
Final check on this unit. Make sure the specs match the tablet.
Everything aligns perfectly. Move it to QA.
Check the schematics for the turret ring alignment.
Already on it, verifying tolerances now.
The M551 Sheridan hull is prepared for its journey to the main assembly line. With practiced ease, the hull is precisely lowered onto its designated position. Precision begins as the powerful Detroit diesel heart is readied for installation. Skilled hands guide the robust engine, ensuring perfect placement within the tank's chassis.
Easy now, watch the clearance on the left side.
Got it.
Just a hair lower.
Clear on this side, keep coming down.
The crucial drive shaft is joined, connecting power to the tank's formidable mobility.
Solid.
With meticulous care, the power pack is fully integrated, a vital step in the tank's combat readiness. Skilled American workers guide the heavy turret with precision tool. The M551 turret gently settles into its designated position on the home.
Check the alignment on this panel right here. Looks solid, ready for sign off.
The newly unified M551 Sheridan stands, a testament to precision engineering. Skilled hands bring the tank's operational systems to life, piece by intricate piece. Every connection is vital, forming the tank's robust and responsive nervous system. From power to targeting, each circuit adds to the Sheridan's formidable capabilities. Advanced diagnostics begin, ensuring every system on the M551 Sheridan is perfectly tuned. Initial commands are loaded, activating the Sheridan's intricate internal systems. Data streams activate, displaying real-time insights into the tank's operational health. Real-time diagnostics confirm the turret's precise motor performance and alignment. Detailed telemetry verifies the gun's elevation system, ensuring pinpoint accuracy.
Let's review the calibration data.
See this critical reading on the hydraulics. It's unstable.
Agreed. I'll adjust the servo valve gain as per the schematic.
All M551 Sheridan systems are verified, ready for the next stage of production. In the factory testing bay, the heart of the M551 Sheridan prepares for its debut. The mighty Detroit diesel engine ignites, filling the bay with its raw power. Workers meticulously monitor banks of gauges, seeking operational perfection. Trained ears detect the slightest anomaly in the engine's powerful song.
Sir?
We need to adjust the fuel injection timing based on these readings.
Agreed. The pressure spike at 2,000 RPM is still too high.
Skilled hands perform fine adjustments, perfecting the engine's performance.
As you can see, the temperature, RPM, and pressure are all running optimally.
Looks good. We are ready for the next phase of testing.
With all checks complete, the engine runs flawlessly, a testament to American engineering. On the proving grounds, the Sheridan's agility and power are rigorously put to the test. The M551 Sheridan, a nimble, light tank, proving its worth on the battlefields of Vietnam. Its rapid deployment and powerful armament made it a crucial asset for American forces. The genesis of the Sukhoi Su-57 Felon begins with the foundation of its stealth high-strength carbon fiber composite. Massive rolls of raw composite are deployed onto the automated cutting bed, prepared for the transformation into a radar-absorbent fuselage. A powerful vacuum system engages, locking the flexible weave into a perfectly flat plane to ensure sub-millimeter accuracy. The automated ultrasonic cutting gantry initializes its robotic systems, calibrating to the digital blueprints of the aircraft's skin. Complex geometric shapes specifically designed to deflect radar waves are excised from the raw material matrix. This ultrasonic process ensures that the edges are perfectly sealed, preventing delamination during high-speed maneuvers. An integrated extraction system removes microscopic debris, keeping the environment sterile for the subsequent bonding phases. Synchronized cutting heads work in tandem, optimizing the production of the large-scale panels required for the wing roots. Each individual piece is digitally serialized for quality control, ensuring total tray assembly process. The process repeats with relentless consistency, transforming rolls of cloth into the skeleton of a fifth-generation fighter. With the cutting sequence complete, the vacuum bed releases its grip, allowing the newly formed panels to be retrieved. What remains is the waste matrix, while the precisely cut skin panels move forward to the next stage of reinforcement. The Su-57's structural integrity begins with its spine individual bulkheads, machined from aerospace-grade titanium. High-precision robotic arms calibrate their position using laser guidance to achieve micron-level accuracy. Each structural component is meticulously positioned within the master assembly jig to form the central keel. Aluminum alloy ribs are integrated, balancing weight reduction with the extreme strength required for high-G maneuvers. Laser-guided welding heads initiate the fusion process, creating bonds stronger than the base metal itself. Controlled heat cycles prevent structural warping, ensuring the airframe remains perfectly aerodynamic. Real-time thermal monitoring ensures the integrity of every weld across the titanium vertebrae. Automated riveting reinforces the assembly, distributing stress loads across the entire internal skeleton. Synchronized robotic coordination allows for the simultaneous assembly of the port and starboard structures. The internal engine nacelles are forged to house the thrust vectoring power plants. Every joint is sealed to prevent corrosion, adding a layer of durability for decades of service. The central weapon bays are integrated directly into the spine to maintain the aircraft's stealth profile. Non-destructive ultrasonic testing confirms there are no microscopic flaws within the titanium forge. The completed skeleton stands ready, a masterpiece of metallurgical engineering. The airframe enters the electromagnetic shielded spray booth, where the environment is purged of all static interference. Precision deionization ensures the surface is perfectly neutral, preventing any microscopic particulate rejection. Advanced electrostatic atomizers are calibrated to apply the coating with micron-level uniformity. A specialized primer layer is applied first, creating the chemical bond necessary for the radar-absorbent material. The initial layer of RAM begins to cloak the metallic signature of the leading edges. The core radar-absorbent material, rich in carbonyl iron, is atomized into a precise electromagnetic barrier. The automated system follows the complex geometry of the Felon's fuselage to eliminate any radar-reflective seams. Critical areas like the engine intakes require extra density to trap and dissipate incoming radar waves. Real-time ultrasonic diagnostics verify the precise thickness of the cloak, ensuring it meets stealth specifications. A second denser layer is applied to the tail fins, further reducing the aircraft's radar cross-section. Stealth geometry is reinforced by the coating, ensuring that door seams remain invisible to sensors. Multi-axis coordination allows the entire upper airframe to be encapsulated in a single continuous process. As the solvents evaporate, the RAM particles lock into a lattice that absorbs and scatters electromagnetic energy. Careful demasking reveals the clean interfaces where the stealth coating meets the cockpit in sensor glass. Final UV inspection ensures there are no microscopic voids in the shadow cloak. The Felon is now fully encapsulated, transformed from a metallic structure into a ghost of the radar spectrum. The shadow cloak application is complete, marking the birth of the airframe's true stealth capability. The heart of the Felon, the AL-41 F1 engine, begins its precision descent via a heavy-duty overhead gantry crane. The primary mounting rails engage, supporting the massive weight of the power plant. Automated systems begin the delicate process of integrating the primary fuel manifolds. The digital nervous system is connected, linking the engine's full authority digital engine control to the main computer. With the first unit seated, the second engine is brought into position to complete the twin engine configuration. Technicians monitor the pressure and alignment telemetry as both units reach their final seating depth. The Signature 3D thrust vectoring nozzles are attached, providing the Felon with its legendary super maneuverability. Hydraulic actuators are integrated into the nozzle gimbal, allowing for multi-axis thrust redirection. Initial range of motion tests verify the sync between the cockpit controls and the nozzle actuators. Advanced thermal shielding is applied to protect the airframe from the intense heat generated by the supercruising engines. Manual inspections ensure no debris or gaps exist in the air intake interface. With the installation complete, the gantry crane is retracted, leaving the twin hearts of the Felon fully integrated. The AL-41 F1 engines are now part of the airframe, ready to propel the Su-57 into the supersonic regime. The integration of the N036 Bielka-A ESA radar begins within the sterile environment of the Avionics bay. A robotic loader precisely positions the main X-band radar chassis, the heart of the Felon's situational awareness. High-torque titanium bolts secure the frame, ensuring the sensitive arrays remain stable during supersonic maneuvers. Liquid cooling lines are engaged, essential for dissipating the immense heat generated by the radar's gallium nitride transmit-receive modules. High-speed fiber optic data links are threaded to the central processor, allowing for near instantaneous signal processing. Simultaneously, secondary side-looking arrays are installed, providing the aircraft with a wide-angle radar field of view. Automated systems perform micro-soldering checks to guarantee the integrity of every data bus connection. Protective composite panels are sealed over the lateral sensors, maintaining the aerodynamic and stealth profile. The ATOL infrared search and track sensor is lowered into its housing, granting the pilot passive thermal detection capabilities. Optical calibration lasers verify the alignment of the IRST, ensuring pinpoint accuracy for long-range targeting. Physical data integration connects the IRST to the electronic pilot AI assistance system. The thousands of individual transmit-receive modules undergo a final UV inspection for surface impurities. Electromagnetic seal testing ensures the radome interface does not disrupt the aircraft's radar-absorbent properties. Initial power-on tests energize the arrays, bringing the aircraft's electronic eyes to life. Diagnostic software confirms a successful handshake between the AESA radar and the central mission computer. With its electronic eye awakened, the felon is now capable of seeing the battlefield long before it is seen. We begin the neural integration by seeding the primary data backbone connecting the airframe's nervous system to the central processor. Fiber optic bundles are routed through the lateral consoles, ensuring lightning-fast communication between flight surfaces and the core AI. The main avionics rack, the brain of the felon, is lowered into its vibration-dampened cradle. Power is introduced to the head-up display, initiating the first stage of the cockpit's life cycle. The fly-by-wire system undergoes its initial self-test, checking the physical responsiveness of the flight controls. Calibration of the head-up display begins, aligning the digital horizon with the aircraft's physical sensors. The electronic pilot AI boot sequence commences, running through millions of lines of code in seconds. System diagnostics verify the integrity of the radar, propulsion, and stealth subsystems. The AI core stabilizes, establishing its interface with the human pilot's control inputs. Thermal management systems activate to dissipate the intense heat generated by the AI's neural processing. Interface illumination is tested, ensuring all physical controls are visible under any combat lighting condition. Touch interface calibration ensures the pilot can command complex systems with simple gestures. Neural network integration is complete. The aircraft's consciousness is now fully operational. From a dark shell to a living machine, the cockpit is now the command center for the world's most advanced fighter. The neural network remains in a state of high readiness, awaiting the first flight commands. The journey from the assembly line to the sky begins as the massive hangar doors at Komsomolsk-on-Amur are part for the first time. Initial power-up protocols engage, cycling the digital fly-by-wire system to ensure every control surface responds to the pilot's intent. With the canopy sealed, the cockpit becomes a pressurized sanctuary for the pilot, integrating man and machine through the AI interface. Taxiing toward the threshold, the aircraft's weight rests on its heavy-duty landing gear, designed for the rigors of frontline operations. At the runway threshold, the felon pauses, aligning its nose with the horizon it is about to conquer. Thrust vectoring nozzles calibrate, preparing to direct the massive energy required for a high-performance takeoff. Brakes release. Potential energy transforms into kinetic force as the aircraft begins its high-speed sprint. Speed builds exponentially. The airframe begins to generate lift, straining to break its terrestrial bonds. Afterburners engage, providing the raw, unbridled power needed to achieve flight velocity in seconds. Rotation. The nose pitches up, transitioning the angle of attack for the final leap into the sky. Weightless. The transition to flight is complete as the Komsomolsk soil falls away. Immediately, the hydraulic heart of the aircraft pumps high-pressure fluid to begin the retraction sequence. Internal actuators pull the massive landing gear into the fuselage, streamlining the aircraft for supersonic travel. Born from the factory floor, the Felon now belongs to the clouds, a master of its new domain. To master the regime of post-stall flight, we begin with the Su-57 in a stabilized subsonic cruise. The Levcon controllers are unique aerodynamic surfaces designed to manage airflow over the wings at extreme angles. As the maneuver initiates, these surfaces articulate to generate controlled vortices, maintaining lift where other aircraft would stall. Simultaneously, the 3D thrust vectoring nozzles of the AL-41 F1 engines prepare for rapid deflection. By redirecting the engines thrust independently of the wings, the pilot gains direct control over the aircraft's pitch. The Pugachev's Cobra begins. The nose rises sharply as the Levcons maximize the vortex lift. The airframe experiences massive structural loads mitigated by the high-strength titanium skeleton. Every component is stressed to its limit as the aircraft pushes into the post-stall regime. At this angle, traditional control surfaces lose effectiveness, leaving the Levcons to maintain lateral stability. The 3D thrust vectoring provides the necessary force to push the airframe beyond the vertical. Now vertical, the aircraft is essentially a controlled ballistic object held in space by thrust and vortex flow. At 110 degrees, the Felon exhibits its supreme maneuverability, a feat of digital fly-by-wire integration. In this moment of zero airspeed stability, the electronic pilot calculates the recovery sequence. Recovery begins. The vectoring nozzles force the nose back down toward the horizon. As the air reattaches to the wings, the aircraft regains aerodynamic flight from the post-stall state. The Levcon controllers return to their aerodynamic profile, securing the stealth signature. Stability is restored. The 3D thrust vectoring nozzles resume standard operation for fuel-efficient supercruise. The vortex has been mastered, proving the Su-57's dominance in high angle of attack air combat. Phase 9 begins with the activation of the hidden claws, starting at the seamless interface of the internal weapon base. Hydraulic pressure surges through the airframe, preparing the heavy mechanisms for rapid deployment. The airtight seals break, revealing the jagged edges designed to maintain a low radar cross-section even during opening cycles. The doors retract with synchronized precision, exposing the cavernous interior structural ribs of the weapon base. Empty ejection launchers stand ready, their telescopic rails calibrated for high-speed missile deployment. The automated loader maneuvers into position, its robotic cradle carrying the heavy R-37M air-to-air missile. The precision-guided interceptor is lifted with millimeter accuracy toward the forward ejection station. Digital sensors align the missile's hardpoints with the launcher's heavy-duty mounting hooks. Engagement is confirmed with a mechanical lock securing the first of many long-range threats. The data link umbilical is established in allowing the aircraft's AI to communicate directly with the missile's seeker head. With the first unit secured, the loader retracts, leaving the missile suspended in the belly of the Felon. A second long-range missile is elevated into the parallel bay, maintaining the aircraft's center of gravity. The secondary locking sequence completes, doubling the aircraft's long-range air-to-air lethality. The payload shifts to air-to-ground capability, with the introduction of the KH-59 Mach 2 stealth cruise missile. This heavy-duty launcher engagement provides the Felon with its deep strike standoff capabilities. Automated systems torque the mounting bolts to exact specifications, ensuring stability during high-G maneuvers. The internal configuration is complete optimized for a minimal radar footprint in maximum tactical impact. The hidden claws are stowed as the bay doors seal, returning the Su-57 to its clean aerodynamic and invisible profile. The Su-57 establishes a secure, encrypted data link, initiating the digital pack coordination. In the Loyal Wingman configuration, the aircraft synchronizes tactical data with the S-70 Okhotnik B drone. Targeting coordinates are seamlessly transferred, extending the Su-57's sensor reach through its drone pack. The SH-121 radar suite processes high-resolution ground mapping for precision strike authorization. Maintaining its stealth profile, the internal weapon bay deploys a precision-guided cruise missile. The strike is executed with surgical precision verified by the aircraft's integrated BDA systems. Mission complete, the pilot utilizes 3D thrust vectoring to execute a rapid exit maneuver from the engagement zone. As the sortie concludes, the heavy-duty landing gear is deployed for the return to base. The aircraft touches down at the Komsomolsk-on-Amur airfield, its drag chute stabilizing the deceleration. The aircraft enters the controlled environment of the automated diagnostic bay. An automated ground-based scanner initiates a comprehensive surface integrity check. The system identifies microscopic degradations in the radar-absorbent material caused by high-speed flight friction. Robotic applicators perform localized maintenance, restoring the aircraft's stealth signature to peak performance. High-speed data umbilicals are connected to download flight telemetry and mission logs. The mission data is analyzed by the AI electronic pilot to optimize future flight control algorithms. With the aircraft secured and data synchronized, the operational cycle concludes. The Su-57 Felon rests ready for its next mission into the contested skies of the future. The birth of a Merkava Mark IV begins in the white heat of the blast furnace, where ballistic steel is refined to a perfect liquid state. The molten metal is channeled into a single-piece mold designed to create the Merkava's signature monolithic lower hull. This casting process eliminates structural weak points, providing a foundation that can withstand the most extreme kinetic impacts. Special attention is paid to the forward compartment, uniquely designed to house the engine as a secondary layer of crew protection. Every channel and cavity within the mold is precision engineered to ensure uniform thickness across the entire ballistic structure. Complex internal geometries are formed using specialized cores, allowing for the integration of the tank's hydropneumatic systems. Once the mold reaches capacity, the liquid steel undergoes a settling process to remove any microscopic air pockets. Impurities are meticulously removed, leaving only the highest grade high-strength steel for the final hull. Controlled cooling begins. This phase is critical to achieving the specific crystalline structure required for ballistic resilience. As the temperature drops, the steel undergoes a molecular transformation, hardening into a formidable armored shell. The molten genesis is complete. The liquid fire has become the unyielding bone of the Merkava. The manufacturing floor prepares for the extraction of the massive casting weighing dozens of tons. For the first time, the iconic shape of the Mark IV hull emerges from its subterranean birthplace. The temporary casting supports are discarded, revealing the precision cast engine bay and crew compartment. Initial finishing begins immediately, removing excess material from the casting process while the steel is still malleable. Precision cleaning of the internal steel pockets ensures a perfect molecular band for the upcoming inserts. Alignment is verified to within microns, ensuring maximum kinetic energy dissipation across the armor surface. Modular steel plating is layered over the ceramic core, creating the first stage of the multi-layered defense. The high-pressure hydraulic forge activates, exerting hundreds of tons of force to laminate the layers. Thermal bonding fuses the ceramic and steel components into a single indestructible composite unit. Post-bonding inspection reveals a perfect molecular interface essential for structural integrity. Reinforcement proceeds to the critical side skirt zones where modular armor provides vital flanking protection. A secondary alloy mesh is integrated into the side modules to provide multi-hit capability against shaped charges. Precision laser welding seals the outer shell, encasing the composite materials in a steel cocoon. Rapid cryogenic cooling stabilizes the crystalline structure of the armor, preventing stress fractures. Non-destructive X-ray testing but confirms the absence of internal voids or delamination in the composite core. Surfaces are ground to sub-millimeter tolerances to ensure the modular armor blocks fit perfectly. The frontal glacis receives its final high-density compression, completing the tank's most impenetrable section. With the ceramic core successfully infused, the Merkava's hull is now a formidable fortress ready for engine integration. Preparation begins in the forward compartment, where every surface is treated to withstand extreme mechanical stress. Precision alignment is critical. The engine's position is measured to within fractions of a millimeter. This forward engine configuration is a unique design choice, prioritizing crew survivability above all else. High torque fasteners secure the powerhouse, ensuring it remains a stable shield even under intense fire. Reinforced fuel lines are connected, designed to remain intact during the violent vibrations of cross-country movement. Advanced cooling systems are installed to manage the immense heat generated by 1,500 horsepower. Desert-ready air filtration ensures the V12 breathes clean air even in the thick of a dust storm. The exhaust is routed specifically to minimize the tank's thermal signature from the front. A secondary armored bulkhead is installed, providing a final layer of protection for the tank's occupants. Structural integrity is reinforced, fusing the engine's housing into the very skeleton of the hull. The transmission is primed, ready to translate raw torque into battlefield mobility. A final digital sweep confirms that every component is perfectly seated within the chassis. The forward heart beats for the first time, proving the machine's power and reliability. With the engine secured, the Merkava Mark IV now possesses its most defining characteristic, a shield of steel and power. The integration of the main armament begins with the precision lubrication of the turret ring assembly. The MG253 smoothbore gun a masterpiece of ballistic engineering, is positioned for mounting. Engineers oversee the insertion of the breech block designed to withstand extreme chamber pressures. The precision crane lowers the entire artillery assembly into the reinforced turret cradle. The dual recoil buffers are installed to absorb the immense energy of the 120mm discharge. The barrel is perfectly aligned with the turret mantlet using high-precision laser telemetry. Forged steel trunnion pins are seated, creating the pivot point for vertical elevation. The elevation actuators are engaged, linking the gun to the computerized fire control system. The bore evacuator is fitted to prevent toxic propellant gases from entering the crew compartment. Initial elevation tests verify the mechanical range of motion for the smoothbore system. Depression limits are tested, crucial for the Merkava's hull-down combat tactics. Optical and laser range-finding sensors are aligned with the gun's primary axis. The turret is permanently mated to the hull, securing the smoothbore fist to the chassis. Fiber optic data lines are connected, providing the high-speed throughput required for millisecond threat detection. The first of 4 Elta radar antennas is seated, forming the eyes of the tank's defensive perimeter. Symmetry is vital. The second radar unit is installed to provide full frontal hemispherical coverage. Laser-guided alignment ensures there are no blind spots in the radar's 360-degree field of view. With the 4th panel in place, the trophy system achieves total situational awareness around the hull. The central processing unit, the brain of the active shield, is housed deep within the turret for maximum protection. The interceptor magazines containing the hard kill countermeasures are prepared for docking. The magazines lock into the launchers, establishing a physical link to the fire control system. Servo motor calibration begins, ensuring the launchers can track incoming missiles at supersonic speeds. Dual launchers provide redundant protection, allowing the Merkava to engage multiple threats simultaneously. Main power is routed from the tank's V12 engine generators to the Hydra APS capacitors. System handshake complete. The software synchronizes the radar data with the interceptor firing solution. The trophy integration is finished, transforming the Merkava Mark IV into an impenetrable armored fortress. The transformation into a network powerhouse begins with the installation of high-speed fiber optic data buses. These cables form the backbone of the Digital Army Battle Management System, allowing instantaneous data transfer. The main processing core is secured within a hardened, shock-resistant housing to survive the rigors of the battlefield. Thermal management is critical for maintaining peak electronic performance during prolonged, high-intensity operations. The crew interfaces are mounted, providing the gunner with a comprehensive digital tactical picture. The commander station is integrated, merging sensor feeds into a unified command and control interface. External communication arrays are linked, connecting the Merkava to the wider Digital Army network. External situational awareness cameras are synced, eliminating blind spots for the driver. System diagnostics verify the integrity of the networked architecture across all crew stations. Transitioning to the rear, the unique clamshell door system begins its mechanical integration. High-pressure hydraulic pistons are installed to facilitate the rapid opening and closing of the rear access. The lower ramp is fitted, creating the unique exit path for crew evacuation or infantry support. Industrial-grade seals are applied to ensure the rear compartment remains NBC protected and watertight. Digital sensors are integrated to alert the crew of the door's status via the battle management system. Reinforced locking lugs engage, securing the rear portal against external kinetic threats. The digital nervous system is now fully online, transforming a mechanical titan into a networked predator. Before the skin is applied, ionized air purifies the ballistic steel of every microscopic impurity. A zinc-rich primer creates the essential bond between the steel and its future thermal defenses. Rapid UV curing ensures the base layer is chemically locked, preparing for the infrared reflective coating. The infrared reflective base coat is applied, designed to scatter thermal energy and minimize the tank's heat signature. Atomized pigments are layered with precision, creating a surface that mimics the spectral properties of desert sand. Critical sensors are protected as the final protective layers are prepared for application. Non-linear patterns are introduced to break up the tank's silhouette against the shifting dunes of the Negev. An anti-slip texture infused with ceramic beads is applied to the top surfaces, ensuring crew safety during high-speed maneuvers. Validation begins. The IRR coating is tested to ensure it masks the internal heat of the machine from enemy sensors. On the factory floor, the 600mm heavy-duty tracks are laid out ready to support the 65-ton Fortress. The drive sprocket engages, beginning the process of wrapping the tank in its massive steel shoes. A hydraulic winch pulls the multi-ton track over the return rollers with calculated force. The track tensioning system activates, extending the idler wheel to achieve the perfect balance of flexibility and grip. The hydropneumatic suspension adjusts instantly, compensating for the weight of the new steel tread. Every bolt is torqued to precise specifications, ensuring the tracks can withstand extreme cross-country stress. The first rotation, the 600mm tracks move with a rhythmic power that signals the tank is ready to crawl. The Merkava Mark IV stands complete, a desert-colored Predator, armored, tracked, and ready for deployment. Validation begins in the crucible of the Negev, where the terrain provides the first true test of the Merkava's structural integrity. Vertical obstacle clearance and steep grade navigation confirm the torque efficiency of the GD 883 Power Pack. Agility testing ensures the tank can maneuver within the confined, treacherous spaces of a mountain pass. The 600mm wide tracks are evaluated for ground pressure distribution and link durability. Engineers monitor the low ground pressure profile, essential for maintaining mobility in shifting dunes. The structural wells of the front-mounted engine compartment are stressed to simulate the violence of modern combat traversal. A simulated incoming threat is launched to validate the system's detection to intercept latency. The battle management system identifies the threat trajectory in milliseconds, calculating the optimal intercept point. The high-precision launcher slews into position, slave to the radar's tracking data. The Mail Ruach interceptor is deployed using a matrix of small projectiles to neutralize the threat at a safe distance. The interception is successful. The incoming missile is destroyed before it can contact the modular armor skin. Post-intercept, the vehicle maneuvers through the kill zone, its thermal signature suppressed by infrared reflective paint. Proving ground sensors log the data, confirming the trophy system's 100% interception rate. Physical and electronic trials complete the individual unit transitions from a factory machine to a combat-certified asset. The trial by fire is over. The Merkava Mark IV is now ready for deployment to the front lines. The heart of the digital fortress awakens as the battle management system initializes its high-speed processing core. Integrated ELTA radar sensors begin filtering environmental data, identifying potential threats through solid urban obstructions. The advanced fire control computer isolates the target, calculating environmental variables and distance in milliseconds. Precision inputs allow the operator to manipulate the massive turret with the delicacy of a surgeon's scalpel. Moving into a hull-down position, the tank minimizes its profile, leaving only the reinforced turret exposed to the urban corridor. A precision laser rangefinder calculates the exact distance to the target, feeding the data directly into the ballistic computer. The trophy. APS interface enters active mode, creating a protective hemispherical shield around the vehicle. The system compensates for target speed and wind velocity, ensuring a first-round hit probability regardless of movement. Multi-spectral imaging pierces through smoke and light cover, revealing hidden combatants through their thermal signatures. High-torque gyro stabilizers isolate the main armament from the vehicle's movement, maintaining a rock-steady aim. Real-time data networking links the tank to overhead Heron drones, sharing a god's-eye view of the battlefield. Human intuition and machine precision merge as the commander prepares for the decisive engagement. From its concealed position, the Merkava monitors every alleyway and rooftop, a silent sentinel in the concrete jungle. The transition from simulation to combat readiness is complete. The Predator is now the master of the urban domain. Technicians monitor pressure fluctuations, ensuring the system can still handle the extreme vertical loads of cross-country maneuvers. The heavy-duty tracks undergo tension testing, compensating for the wear and tear of abrasive, rocky terrain. Ultrasonic and laser scanners sweep the hull, detecting microfractures in the ballistic steel that are invisible to the naked eye. The internal mortar system is replenished, providing the crew with organic tactical smoke and illumination capabilities. Damaged armor modules are swapped in minutes, a testament to the Merkava's design for rapid battlefield sustainment. The Digital Army Battle Management System reestablishes high-bandwidth links with overhead Heron drones for real-time intelligence. With the rear access doors sealed, the crew compartment is fully protected against CBRN threats and kinetic impact. The fire control system undergoes a final self-calibration, aligning the thermal sights with the 120mm smoothbore gun. The infrared reflective coating is inspected, ensuring the tank remains a ghost on the thermal sensors of the enemy. Deployment begins. The Merkava takes its position as the tip of the spear in a coordinated multi-domain assault. Built for survivability and engineered for dominance, it stands as the ultimate synthesis of armor firepower and intelligence.